Okay. Tanisha, Aruna. Who is this? Aruna?
Sir, of Chakra. I asked the team
Oh,
to change my name, but they didn't.
okay, okay. Yes, you Chakrika and you Abdullah. Please turn on the camera, everybody. Right? I have told you so many times. I need to have an eye-to-eye contact between the students and the teacher so that we can know that whether you are getting the things or not. Okay. Face expressions are very important. Okay. So just a minute. If my voice is clearly audible to you, okay, chalo, start with that. So in the previous class, we were discussing that we have discussed this one, the properties of matter. Yeah. And the next characteristics of particle of matter is this one, that particles of matter attract each other. How can we say that particles of matter attract each other? Is there anyone who can explain me? Particles of matter attract each other.
So we did this.
We did this one also. Yes, you,
Yes.
Tanisha, we have done this one or not? Done. Okay.
Yes, sir. Yes, sir.
Uh, okay. So we shall be moving to the next part. Is this one? Just एक मिनट. We shall be moving towards the that is its states of matter. We shall be going to discuss states of matter. Solid, liquid, and gas that you are very much that is you have already studied. Okay. Okay. So if I'm going to discuss that states of matter, as you popularly know that they are the three states of matter: solid, liquid, and gas. And we shall be going to discuss each of them one by one. Okay. So one is solid. 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 As you know that solids in solid the particles are tightly packed and they vibrate about their mean position. Mean position. Okay. These are the solid particles. They are tightly packed and they are not free to move. That's why. But still they also have a space between them. We call them voids. Okay. So we have studied the characteristics of particles of matter, that particles of matter have a space between them. So, like for example, have you ever heard about the alloys? Alloys? किसी ने सुना alloys के बारे में? So steel is an alloy. Steel. Steel is an alloy, okay, in which two or more metals or metals and non-metals are mixed together. Like for example, if I'm talking, this is an iron particles, iron strip, Fe. Iron, the formula of iron is Fe, okay, ferrous, Fe. So this is the iron atoms, right? These are the iron atoms. And if we add carbon atoms to it, if we add carbon atoms to it, okay, this is the carbon atom. Carbon atom is smaller in size as comparison to iron atoms. So the carbon atom can easily fit. Carbon atom can easily fit in this one. This is the carbon atom, and it can comes in the voids. Okay. So if if the solid don't have a space between them, then how this carbon atom can settle in between the voids? Okay, it is not possible. So particles of matters have a space between them, even though the solids also have a space between them, and these are called voids. Okay. When we add carbon particle to it, it goes into these voids, which was empty space, and it make it hard and make it distort. Means otherwise it can easily distort. Means this shape, this slides can easily slide over the other. Okay. Like for example, if I'm just taking this one, just a minute, let me show you. Okay. So if I just copy this one and so this slide, this like this one. Okay. If I'm talking about this one, so this atom, this particles of atoms can come over here. Okay, like if I'm taking this one, Okay, so if there is no carbon atom present here, like for example, if I'm taking this is not a carbon atoms are not present here, okay, then this can easily slide. Okay, this layer can easily slide um, and come into the space between them. It can come easily into the space between them. Here, it can come easily slide is possible. But if we already add some carbon particles here, so it cannot slide. So it can come over like this way, like this way. If I'm placing one particle here, another particle here, another particle here. So if the layer can slide, so it can result in that. This is a big displacement, okay, and can result in the change in shape. You can see that this is not a little change, okay. The atoms are low. So for example, if we want to uh, load heavy machineries, or if we have to make heavy machineries, and if we want to make it iron very strong, so that the heavy railway tracks are made up of this one, so we add carbon particles and carbon between them like this way, and in order to prevent the distortion, so that it cannot slide over one another. So atoms of carbon atoms also have, or sorry, we can say that atoms of iron also have a space between them. They also have a space between them. Are you getting my? And we can add small carbon or some other particles to it, so that it will prevent a distortion. It cannot let it to slide, and it does not let it to change the shape of matter. Otherwise, it can easily distort its shape, which can result in accidents. Okay. So this I'm talking about the solids. So solids particles have very high force of attraction between them. Okay. Metals. Okay. And why do metals have high force of attraction? Let me tell you that, as you have already been studying since childhood, that these are the atoms which are carrying nucleus, and in this atom there are electrons that revolve around the nucleus, that you will study uh, in the structure of atom. Okay, don't worry if you don't know about this one. Let it be. It's normal. So one, two, three. So these are the electrons that revolve, and metals are very electron rich. Metals are very electron rich. So if this is another atom like this way, or this is another atom which is very nearer to this one. Okay, this is another atom. So what happened here is that, okay, this is another atom. So sometimes the electrons easily can jump from this one to this one. Okay, like one, two, three, four, five, six, seven, eight. So since metals are very electron rich, so they can easily jump. They can easily jump. One, two, three, four. Okay. They can jump from this or this element to this one. Okay. And from this one to this one, they can easily jump. Okay. That's why we called it free electrons. And free electrons make it metals to conduct electricity. Okay. So if the electron can easily jump from one atom to another atom, so if, like for example, here the three electron get jumped from here, so electrons are negatively charged. So if negative charge, like for example, if I'm explaining you that this is a particle, that is, these are the four particles, one, two, three, four, five, and these are carrying five positive charge, and this is the electron that is carrying five negative charge. Five, these are the electron. These are the, this is the proton actually. Proton are positively charged, that you will study. I think you have studied in the 8th standard also. And this is negative charge, five negative charge. So when they both are equal, then it will be going to have zero charge. No charge is there. But what if three electrons goes from it? Then it will be P, the five positive charge, and only two negative charge. So what is the resultant of this one? It will become positive charge. Means three positive charge will come, extra three positive charge will come. So when the electron jumps from this to this, so it will become positive charge. And when it gains electron, it becomes negative charge. So this negative and positive charge is very strong. And this is called metallic bond. We called it metallic bond. So since the atoms are very close to each other, the electrons between them can easily jump to this one, and resulting in metallic bond. We called it metallic bond, and that is very strong. Are you getting my point? समझ आया? So atoms of metals are tightly packed together. Like you have seen the chalk. Chalk is not tightly packed because chalk is carrying calcium carbonate, CaCO3. The formula of chalk is CaCO. It's not a metal. But like the other metals, you see that like iron, copper, aluminium, they are having very high melting point. because they are tightly packed, and because of this electrons transformation they form metallic bond. Okay, वो metallic bond बनाते हैं. That's reason is because of that
Excuse me,
ये
sir.
metal. Yes,
I didn't understand the positive negative part.
positive and negative part. Okay, actually, I'm saying that there are two subatomic particles. There are three subatomic particles present in the atoms: proton, electron, and neutron. Okay, proton is positively charged, electron is negatively charged, and neutron is neutral. Neutral. It don't have no charge, zero charge. Okay, so I'm talking about this one. Like for example, if I'm saying that you have positive 5 charge due to the presence of 5 proton, then the neutral atom will also have 5 electrons, 5 negative charge due to 5 electrons. 5 positive, 5 negative, the whole atom will be zero, neutral, no positive, no negative, means equal. But if I add some electron to these atoms, if I add electron to it, let I am adding 2 electron to it. So it will add 2 negative charge, 2 negative charge. Are you getting my point?
Yes, sir.
So like this one, I'm talking about this one, like I'm talking about this chlorine. The chlorine has 17 electron, 17 electron and 17 proton. But if you add one extra electron to it, it will become 18 electron and 17 proton. So that's why the total charge here is zero, because it is negative and positive is zero. But here negative and positive will be -1. 18 electron, negative charge. So we will say that chlorine have -1 charge. Okay. And similarly for the sodium. Sodium has 11 electron and 11 proton. But sodium can donate one of its electron. So if sodium donate, it will have 10 electron and 10 and 11 is still 11 proton. So electron have negative charge, negative, and proton have positive charge, positive. So it will be one positive charge. So when an electron is added, it get negative charge. When electron lose, it get positive charge. So electron in metals can jump from one atom to another atom. They can easily jump. So when they jump and goes to another atom, the another atom will become negative, and from which it is loosened, or it has been it jumped, from which atom it jumped, it become positive. So negative and positive attract. Okay, and there is a very huge force of attraction that is called, means the in this universe the highest force of attraction that is possible is between the is electrostatic force. Electrostatic force is very high. It is, if I am comparing it with the gravitational force, it is approximately 10 raised to the power 39 times more. Means we can say that the ratio of electrostatic force to the gravitational force is 10 raised to the power 39 times to 1. Means electrostatic force is very huge, very huge force. So that's why when an atom gets positive charge, another atom gets negative charge, they are holded tightly together. Okay, and they require large amount of heat energy to get separated. That's why metals have high melting and boiling points. Okay, got
Yes.
it? And solids have high melting and boiling points. So if I'm talking about this one is that atoms, the solids have fixed shape just because of generally their metals are tightly packed. Okay, their element atoms are tightly packed. And if I'm talking about this one, that there is they why do they have high melting and boiling point? The reason behind it that because of the strong electrostatic force of attraction. Okay, or we can say that because of high bond, they are tightly packed. They, or we can simply say that because of high electrostatic force of attraction or metallic bond. We can say this is the metallic bond. Okay, metallic bond, metallic bond. So because of metallic bonds, समझ आया? Hmm?
Yes, sir.
So next is that they have fixed shape. Why do they have fixed shape? The reason behind it is that because they are tightly packed. Shape, how the shape can change? How the shape can change? Like for example, if I rearrange this one, like for example, if I'm having uh, a cup, if I need to make there are four sticks. Okay, there are four sticks, and I need to make cup from it. So I can make cup easily, a cup with the help of four sticks. And if I'm saying that these sticks are fixed, you cannot change the position of these sticks. So it will always remain as cup. Okay, but if you want to make it a chair, For this, what you need to do is you need to rearrange them. You need to rearrange them like this way. So when the rearrangement is possible, then the shape will change. If the rearrangement is not possible, the atom is fixed, they are tightly packed. If the rearrangement is not possible, the shape is not fixed. When the particles are tightly packed, they are not continuously moving. So that's why they have fixed shape. Got it? And they have fixed volume. Volume is also because actually, if I'm saying that why do they have fixed volume? Actually, when the particles are tightly packed, they are tightly packed. Volume in the space occupied by the atoms. Okay. Now, this space cannot be occupied by the same kinds of atom that is present here. It is not possible that one of the any atoms from here anywhere it come and occupy this space. It is not possible. Okay, it is not possible because this they have a space. The different atom of smaller size can come, like carbon can come and fit in here, but it is not possible that the one of the atoms of the same metal or same element come and occupy this space. It is not possible because they are tightly packed. It is not possible that one of the atoms come and escape. So if it is not possible, then we can simply say that they will have the fixed volume. Volume is only possible then, like for example, if something is compressible, we can decrease its size. You can decrease its size. Then we can say that it is compressible. Okay, it is compressible. So only if the volume is changed, volume means the space occupying. If something space is occupying, if you are changing its, like for example, if I am taking the gas particles are very far away. Now, one particle of gas is here. Like for example, if I'm taking the example of oxygen, or I'm taking the example of helium, because helium atom exists individually. So this is helium atom. Helium atom. Okay, so they are moving here and there, but they can, if you compress them, these particles can come closer and take less space because there is already a space with them. So they can take less space here and can be compressed. So if I'm saying that they have fixed volume, indirectly I'm saying that they are incompressible. And if I'm saying okay, if I'm saying that occupy less space, so now I have compressed it, now they come closer, and you can say that they are coming closer and they are occupying less space than the previous one, diagram. Okay, so if I'm saying that solids have fixed shape, fixed volume, shape is just because their particles are not able to rearrange themselves, their shape is fixed, they are stick. And why they also have fixed volume, the reason behind it is very simple. Just because the particles of solids they are already tightly packed, so you cannot press them further. You cannot press it. It is not possible that you can make the atoms of and change its size like this way. It is not possible that you can make the atom and compress the atom and decrease their size. It is not possible. The size of the atom is fixed. So you cannot further compress it. The solids. Okay, understood? Compression is possible where there is large space between the atoms present, and there is no spaces present. Got it?
So,
Yes.
so does compression take place when you cool the substance or when you heat the substance?
When you cool the substance, then the compression will take place because the kinetic energy will decrease and they will come closer to each other. Okay.
Yes.
So this one is possible. Okay. So they are compressible. Okay. And how does this compressibility depends? This compressibility, we will learn this one then when we are going to change the states of matter, that how does solid, that what are the factors that can help us when we are changing the states of matter. Like if we are changing the gas to liquid, then what are the factors? That is it the pressure? If you increase the pressure, will it easily get compressed? If you decrease the temperature, will it get easily compressed? Something like we were going to study. So this is the factor. Now, if I'm talking about this one, that it's okay. We have studied that the particles of matters have a space between them. And if I'm talking about the solid, that solids have fixed shape, fixed volume, and they are tightly packed. They have high melting and boiling points. The next question is that if I'm saying that they do have like this, So if my question is that if I'm having a sponge, okay, if I compress it, it can be easily compressed and it has fixed shape. Why it is so? Can anybody in the class answer me this question? Anybody in the class
Sir,
can
can you
answer?
repeat the question?
I'm asking that if you have a sponge means a sponge, you know what is sponge? Let me show you the sponge. Sponge, everybody
Is
have seen
it
that one?
because like it has small
Yes, sir, I
holes,
know.
Yeah, because it has.
small holes, and then like it's
Yeah,
that.
because it is having air space or holes
Yeah.
in which air is already kept, air is present. No, the material from which sponge is made up of, it is not present at this point. Like for example, this is a hole. So at this hole, no sponge material is here. Okay, the material from which sponge is made up of, it is not present in this position. Okay, in this position. So when you compress it, what is when you are
Air
compressing it,
is coming out from the space.
yeah, then the air will comes out, and in that space the sponge will come. The particle of a sponge will come closer. So up to the certain limits, when the whole air will get out or escape, when you compress it, and then you okay, when the whole air is taken out, then it can be easily compressed. Okay, but after when the whole air is being removed out, you cannot further compress it, because here the air is present. When the air escape, then simply the sponge material will come closer, means this boundary of that, this is the boundary of a sponge, so they will come closer and will fill this space. Okay, so it is possible just because air is present in that. Okay, anything if I'm talking about this one, like for example, if I'm talking about that rubber band, I'm talking about the rubber band. Why rubber band is if you or rubber, if you stretch the rubber band, then it can be easily stretched. I'm checking that solids have fixed shape, they are not, they don't increase. Why I'm saying that? This one, can anybody tell me? And when the force is removed, then it simply regain its position. Simply is that we are taking that solids can change their shape when the force is applied. When the force is applied, then solid can change their shape. Under the action of force, they can change their shape. It is the rubber band that our force is sufficient for it to rubber band material, our force is sufficient to change its shape. Okay. But for changing the shape of an iron box or iron something, we need hammer. Okay. For changing its shape. So we can change the shape. We can stretch the material. Okay. Just by applying the force. Force can change the shape of the material. Like the rubber band also, when we apply the shape, force over
So
it,
it
then it,
depends on the solid, like how much force you need to
yeah,
change it.
yeah, yeah, yeah. It depends on the material. The different material can have different properties. Okay, not this, the force of attraction is not same. I'm saying that solids have same force, high force of attraction. But you can say that what force of attraction, I can break the chalk easily with my hand. Yes, you can break, because the chalk cannot be, if we compare the chalk with the iron rod, it is not possible. It is very goofy. Okay. So chalk particles are not having high force of attraction because they are made up of calcium carbonate, CaCO3. Like a graphite rod, the pencil lead, you can easily break because it is made up of carbon, and carbon is non-metal. It electron do not jump from one to another. Its electron do not jump. They do not form positive and negative atoms. They don't form metallic bonds. So that's why non-metal can easily break. But in metals, like if I'm talking about iron, aluminum, something, so their atoms, electrons easily jump and they can form positive and negative, then positive and negative. And because of that, they have high force of attraction. Got it? They are tightly packed. So force can change the shape of material, but for a rubber band, A human force is enough. For an iron rod, a human force is not enough. So we require some machineries to change the shape of that one. Okay, got it?
So I have one question. We had this question like arrange the following in order of increasing density in the book, and then like according to chemistry, like density like in solids is the highest, and then in liquids it's medium, and then in what is that gas it is the lowest. But then like we had cotton before water, and then like water is a liquid, so and cotton is a solid.
No, it is not. Density depends on the space occupied per unit mass. Actually, the formula of density is volume, mass upon volume, mass per unit volume. Okay, let me explain. Like for example, if you have a glass of water, okay, a normal glass of water, okay, and it is having 900 ml of 900 grams of water, okay, and the volume occupied by it is still 900 ml. Like the volume it is occupying is 900 ml, 900 ml. Okay, so the density of this one will be 90, mass is in grams, and volume is in ml. So 900 upon 900, what you will get? That would be 1 gram per ml. And okay, and this is the actual density of water, 1 gram per ml. But if you add 10 gram of sugar to it, or you get 100 gram of sugar to it, 100 gram of sugar, then when you are adding 100 gram of sugar, so where does the sugar goes? It goes into the intermolecular space of the water. Hmm?
Yes, sir.
And it will occupy that space. Now, the next mass can neither be created nor destroyed. So if you are adding 100 gram of sugar to this one, it will goes into the intermolecular space, and the level of the water will not rise. It will remain exactly the 900 ml because the volume is not increasing. It is not extra occupying space because the sugar goes into the space between. So here the mass is, before is it is 900. Now we have added 100 gram of sugar to it. It is 1000 and divided by 900. The volume is still. So it will become 1000 divided by 900. So when you divide it, you will get 10 by 9. You will get 1.111 gram per centimeter cube. So here the density increases when you are adding something. So same as this, we are talking about the cotton. So cotton initially, when it is not taking water, okay, and it is a simple solid, it is not, it is occupying, let's this is space it is occupying. So that volume is occupying very less mass because cotton is very lighter. But when you add water to it, then that water goes into the space that which was earlier occupied by the air in the cotton. Okay, now that space is filled by water, and water is heavier than air. So density will increase because in the same amount of cotton is occupying much water. Okay, so mass will increase. So simply, it is not necessary that every time the solid is going to have more density as comparison to that of water. There are some substances that are having everything that is having lower density than water, that will sink over it. Sorry, that will float over it. Like for example, if you are having a rubber or a wooden box or a wooden item. So if you are wood is solid, but if you kept it wooden on the water, it float. It float. It means its density is less than water. Everything that is having lighter density, less density than water will float on the surface of water. It will not let it to float because the density of wood is less. So it means that, for example, if you have a wooden piece like this, like you have a wooden piece of something, okay, and it is a three-dimensional box like it is, okay, and its weight is 1 kg, okay, and occupying the space that is, and it is occupying space that is 900 ml, not 1 kg, it is occupying space of 1500 centimeter cube. Okay. It is 1 kg, 1000 grams. Okay. The density of this wooden box will be 1000 divided by 1500. You will get 10 by 15 and you cut it, you will get 2 by 3. That will be 0.66 gram per centimeter cube. But if you have the same dimension and ice box, just imagine that is it. Now this wooden piece is made up of ice. And the same area is occupied, then it will have more weight. Instead of this one, it will have 1500 gram. 1500 grams. So are you getting my point? So now the density will be 1500 divided by 1500, you will get 1 gram per centimeter cube. So you will get the density, the concept of density you will get cleared when you will study the physics, Archimedes principle. In that case, you will study it much better. But I am saying that if the same space, they are the two substances. Like for example, you have a remote which is made up of plastic. Instead of that plastic, if you made that remote of iron or something else, it will occupy the same space that the plastic was occupying, but this time it will be heavier. So same space occupied by two different substances. One is heavier, another is lighter in weight. So one which is lighter will have less density, one which is heavier will have high density. Are you getting my point? If your copy, imagine your copy notebook. Instead of that notebook, this is also solid made up of paper. But instead of this paper, if you have aluminium paper of same thickness, then it will weight more than your copy. Or iron, it will weight twice. So that's why we'll say that same material for the same space, different material for same space can have different weights. One which have occupying in the same space, one which is occupying more mass have more density. This will be cleared when you are going to. It is not necessary that solids will have always more density. Lithium that is have very less density. It is 0.5 gram per centimeter cube. And mercury is liquid which is having 13.6 gram per centimeter cube density, and water has 1 gram per centimeter cube. So there are different many solids that are that are having less density than mercury. That is having less density than mercury. There are many solids. So it is not necessary that solids will have. Generally, we say that solids have high density. Generally, we say. Okay. Got it? Got it, Naisha?
Yes, sir.
Okay. So, dear students, please start writing this one. That's about the solids.
So I have a doubt.
Let's go slowly.
What's the difference between fluids and liquids?
Fluids and liquids.
Yeah.
Anything that can flow is called liquid. Sorry, anything that can means all liquids are fluids because they can flow.
Yes,
All
sir.
gases are fluid because they can flow. So anything that can flow is called fluids.
So both of them are same.
No. Both are, we can say that in gas, the particles are not having fixed volume, something like that. We have different parameter for the liquid and gases, but they can easily flow. So the things that can flow are called fluids. A gas can easily flow in the pipe, and the water can easily flow in the pipe. So that one thing that air can flow is called fluids. Both gases and liquids are both are fluids. Okay.
Yes.
So dear student, please start writing that the physical states of matters are solid, liquid, and gas. Okay? Don't write this one. Done. Write down this one, please. Characteristics of solids, if they have definite shape. I told you that why do they have definite shape? Because they are tightly packed and they are not movable. The particles cannot rearrange themselves. That's why. They have distinct boundaries. Means you can easily, your laptop, your mobile phone have a boundary. You can easily distinguish that from here to here is laptop, from here to here is mobile phone. They are rigid and incompressible because they don't have a space and they have definite volume. These two are actually, uh, if one of them is not possible, then if they have fixed definite volume, it means if they don't have definite volume means they can be easily compressed. Okay, so these two are interlinked. Okay. System. Okay.
So do we have to also write the question and answers? Why is there a
Yeah, you have to write it. But these questions are incomplete. This image is not. So that's why you need to write it properly. Yeah.
So I think we also have the answers in our textbook.
What do you say? Speak it.
I think we have the answer in our textbook on page number 6. No, on page number yeah,
Six.
on page number 4.
Page number so that by rubber band considered as solid even though it can change the shape. This question's answer is there in your NCERT, no? Is it
So
there? Is it there? Okay, it
is
might be. It might be. It's okay. Start doing this one, please. Is it visible to you? Yeah, that's visible. Right? My camera is not showing the version. Done?
No, sir.
Please note it down. When you're done, please let me know.
Excuse me, sir, done.
Oh, let's wait for other also. Write down this one, please. Why is sponge considered as a solid even though it can be compressed? Then, Sagarika, are you there? Sagarika, are you there?
Yes, sir, I'm there.
You done?
I'm in the last line for the second question.
Okay. Anisha, are you there?
Yes, sir.
Okay.
Yes, sir.
So, please take the screenshot of this one because you missed the class and then you're going to hear that. So you have to write it down that why sponge is considered.
I'm done with the second question.
Have you taken this one? The second questions, Anisha?
I'm done with it, sir.
Okay. So next is uh, if I'm talking about this one, that if you are just you have done this many times that the the box, if I'm talking about the box of sugar or salt is not fixed. Okay, like in many households or not even a okay, there are some cylindrical box for the sugar. Okay, some have this kind of box for sugar. Okay, this kind of box for sugar. Some have a square shape box for sugar or salt. Okay, so if I'm talking about this one, that why they do a different. If I'm talking about the sugar or something. Okay, uh, sugar or salt. You came to the market. You bring a packet of sugar or salt, and you add it to the uh, to the box in which you usually kept the sugar. Okay, or salt. But it takes the shape of that container. And we are saying that solids are fixed. They have fixed shape. So why do they are taking the shape of the container like the liquids does? Can anybody answer me this question? That if you put it into the square shape, then it will take the shape of a square.
Oh,
The salt
sir,
pack.
it's because like an individual sugar crystal still has its shape, but then like when it's all together, it takes the shape of the container. But then if you look at the individual sugar crystal, it shows that why it's a solid, because like it won't change its shape.
Very good. Proud of you. The same thing. Because if you take the structure crystal of sugar, it is not changing the shape. It is the number of particles that can rearrange themselves in different patterns. If they are arranging themselves like this way, so they can fit themselves in the rods. Okay, if you put them in a spherical shape, they can arrange themselves like this way. So the individual crystal is not changing its shape. Individual crystals is not changing the shape. Okay, but we can simply say that the arrangements can be different. Like for example, if the particle arrange themselves, one particle is here, other particle is here, another particle is here, so they can take the shape of the container like this way. They are arranging themselves, but the individual crystals are not changing the shape. Got it? And if they start taking the shape like this way, they can easily take the shape of this one. Got it? But the individual crystal shape is fixed. It is not changing. So it is the individual crystal whose shape is fixed. It is not changing, but due to different rearrangement, it can take the shape of different. Okay, got it? So please note this one also. Uh, question is that why the salt and sugar considered solids even though they can take the shape of the container in which they are kept?